So after that, before going into the design of anything, we have to first analyze the types of failure. Yes or no? So if we consider bolted connection or welded connection, so first we have analyzed the failures and then we have gone for the design. Okay, so the next topic is design of tension members. So far we have completed the discussion of plastic analysis and the connections. In that connections, we have discussed in and out about bolted connections, that is concentric and eccentric connections, and then welded connections. So the most important or you can say the major part in this design of steel structure is completed. So as I said, 4 marks for sure. Whatever we have discussed so far, from that 4 marks for sure. So now the topics, whatever we left. So in these topics, 1 to 2 marks, that's it. So rarely the question will come or not, we cannot say rarely, but the frequency is very less. But the topics, whatever we have discussed so far, will have very high frequency. Okay, more frequently the question have been asked from the topics what we have discussed so far, that is connections and plastic analysis. So now the topics, the coming topics, that is design of tension members and then design of compression members, beams, industrial roofs and all those things. So from all these topics, we are going to get 1 to 2 marks. Okay, so that too we cannot guarantee every year there exists a 1 to 2 marks, but there exists 1 to 2 marks, but we don't know when that 1 to 2 marks will come. But for sure, more chance are there to get 1 to 2 marks. So now in that the first topic is design of tension members. We know what is meant by tension. So tension is nothing but if the two forces, two opposite and equal forces acting away from each other is known as tension. Clear or not? So now we have to design that tension member. Clear? We have to design that tension member. So coming to the tension member, so before going into the design, we have to see some effects like shear lag effect. So shear lag effect. So this I will explain within a diagram. So first I will give the definition, after that I will explain. The non-uniform straining of members is called as shear lag effect. Shear lag effect. So I'll explain within a diagram. So this is one member, a plate or whatever it may be. So to this member there exists a forces here and here like this. Now because of this force, if you observe the straining, the straining will be like this. So now if you observe, there exists a n number of fibers from top to bottom or from ear to ear. So here the fiber has elongated by this amount, and after that the less amount, and after that the minimum amount at the center, and again at this bottom extreme fiber more. So in this way there exists non-uniform straining. This is known as shear lag effect. Okay, this is known as shear lag effect. So mainly the shear lag effect arises due to eccentricity of load. Okay, eccentricity of load or some other reasons. Clear? So this is shear lag effect. So simply to say, whatever may be the reasons, but the shear lag effect is nothing but non-uniform straining of the member. Clear? For example, if the same force is exactly at the center. Clear? So if I take the same force at the center, same member and the force at the center. So if the force is exactly at the center. Now because of this, how the fibers will elongate or extend? Like this. There exists a uniform straining on both sides throughout the depth. Yes or no? So shear lag effect is nothing but non-uniform straining like this. Clear? At extreme fiber, strain is maximum, at the center less. So non-uniform straining. See, not in all the cases, this is not the pattern, okay? This is not the pattern in all the cases. So this is a just example. So shear lag is nothing but non-uniform straining. That is what you should remember. So don't remember this pattern, okay? This is only for This training pattern is only for this type of loading. Not in all the cases this type of load exists. Okay. This is known as shear lag effect. So in tension members, the one of the undesirable effect is the shear lag effect. Okay, this is the shear lag effect. So take it down. So whenever we are designing a shear lag effect, so we have to take care of that shear lag effect and we have to design the tension member. So this is the one of the undesirable effect in the design of tension members, like buckling in compression member. Yes or no? So in buckling, in compression members, the buckling is one of the desirable effect. So as far as possible, we have to eliminate or we have to control the buckling in compression member. In the same way, for tension member, the shear lag effect is undesirable effect. As far as possible, we have to eliminate it or we have to control it or we have to take care of this shear lag effect in our design. That is the thing. Okay, take it on. So this is shear lag effect. I'm going to rub this. So after that, before going into the design of anything, we have to first analyze the types of failure. Yes or no? So if we consider bolted connection or welded connection, so first we have analyzed the failures and then we have gone for the design. Clear? Here also first we have to analyze the failures and then we have to go for the design. So now types of failures. So first, cross section yielding. Second, net section rupture. Third, block shear failure. So these are the types of failures that the tension members are subjected to. Our tension member fails in either any of these three. Okay, any of these three. Either they may fail by cross section yielding or net section rupture or block shear failure. Clear? So these are the types of failures. So what is cross section yielding and what is net section rupture and what is block shear failure? We'll discuss in detail one by one. Okay.